So we did not statements yesterday. So there's a video about those if you're struggling. Let's go to the next one. The next one is and statements. Now, when I say you have to have vegetables and fruit, what does that mean? You have to have both. So when we're talking about two events, A and B, we're saying the probability that A and B occur. That means both A and B have to happen. For example, if I want to figure out the probability to draw a king and a heart out of a deck of cards, right? That means I have to draw, there's one card that satisfies that stipulation. It's the king of hearts, right? So I have to draw that card in order for me to satisfy that. I draw both a king and a heart. Does that make sense? Does that make sense? Yeah? Okay. Or the probability that I'll wear brown shoes when it rains. I have to have on brown shoes, and it has to be raining. They both have to happen. Does that make sense? Okay. So and statements. In an and statement, both events need to occur. Probability of A and B is the probability that events A and B both occur. So you guys can fill your notes in with those two statements. So where it says and statements, I want you to write this. Where it says probability of A and B, I want you to write this. Okay. And then we'll get to the multiplication rule here in a second. Now you take notes. You need a new paper? Put it on the paper. You have anything? Write down your notes. Okay, stop talking then. Andre, don't say that. I have to have an appointment with Miss Kozo.
I said I was going to kill myself when I got my teeth pulled out.
So now you have to have an appointment with Miss
Mister, I wrote that on the board. What do you want?
Yeah. Where do I want to trade them? Where is the and statements?
It doesn't say and. Yes, it does on the other side. Stupid.
Don't call your best friend stupid.
That's the best thing to say.
Okay. Any questions about and statements? Okay. Now, in the past when we did and statements, we looked at a sample space, right? So when we were talking about the four-section spinner and the four-sided die, we had to make a table of all the outcomes, right? Remember that? We made a table of all the possible outcomes. Look like the one I have over there in blue. You guys remember that table?
Yes.
Okay. So that table we could use to find the and statements, right? Right?
Yeah.
Okay. So if I wanted to find the probability I roll a 3 and spin a B, what do I look for? Roll a 3 and spin a B. The probability I roll a B, or roll a 3 and spin a B, right? Where are they on here?
Right there.
Okay, the B row and the 3 row, right? Right? How many times do I do both? Once. That 1 out of 16. In order to get that answer, I had to make the sample space, didn't I?
Yep.
Okay. I'm going to show you a quicker way. Instead of making that big sample space, remember the answer was 1 out of 16. Instead of making that big sample space, we can think about the probability of rolling a 3. What's the probability of rolling a 3 on a four-sided die? 1 out of 4. Right? Just like all of these, rolling a 1, rolling a 2, rolling a 4. They all have a probability of 1 out of 4. Right? 25%. With the four-section spinner, since there are 4 equally spaced sections, their probabilities are all 1 over 4. Right? So using the multiplication rule, I can arrive at an answer for the probability of A and B without making a sample space. Okay, so the probability I roll a 3 and spin a B, right down here. The probability I roll a 3 and spin a B. What's the probability of rolling a 3? 1/4. What's the probability of spinning a B? 1/4. So the probability of doing both is 1/4 times 1/4. What does that equal? No, it does not equal 2/8. You added long. What is it, Bruno? 1 over 16. Okay? Because if I multiply 1/4 times 1/4. Remember, multiplying fractions, you multiply across the top, 1 times 1. You multiply across the bottom, 4 times 4, 16. So we get 1 over 16. Does that make sense? If you need to use your calculator, that's fine. Right. Any questions? Any questions? Okay, let's try this next one. What's the probability of not rolling a 2? How many 2s are there? 1. How many total outcomes? 4. So how many of these are not 2s?
3.
3, right? So the probability of not rolling a 2 is 3/4, right?
Yep.
What's the probability of spinning a C?
1 over 4.
1 over 4. So instead of doing 1/4 times 1/4, the probability of not 2 is 3/4. The probability of C is 1/4. 3/4 times 1/4. 3 times 1 is 3. 4 times 4 is 16. So the probability is 3 out of 16. Does that make sense? Spin a C and not a 2. Let's check our sample space to make sure it's true. So back over here at our sample space. Okay? Not a 2. That means any number that's not a 2, right? And a C. So that means we have C1, C2, and C4. 3 out of 16. Does that make sense? No?
Because you said C1, C2, and C4.
Right. Because it can't be. Oh, sorry. C1, C3, and C4. It can't be a 2. Thank you. So not a 2 means nothing in this row and a C. So I can't be in this row. Got to be a C. So the only one that's not in that row and a C is C1, C3, and C4. Thank you. So that's 3 out of 16. Is that cleared up, Long?
Yep.
Yeah. Any other questions? All right. I'd like you to try the other 4 examples on your page. Okay, you have 4 more and examples on your page. I'd like you to try those out. Okay, put your crossword puzzle away. Yes. I do have that. What, you gonna trade me there, polar bear? A what? Your ID? Oh, I was hoping for like $1, and you can forget. You have $1.
$3.
What?
$3.
$3?
Oh, what a cute picture.
You're good.
I'm just joking, David. Why do you chew on your ID?
Yep.
Oh, how the corner ripped off?
I tore them off.
Oh, you tore them off?
It's cold outside. It is. I like it so much. Today feels like a Monday. I don't feel like a Friday, but I don't know about Monday. Friday? I mean, Wednesday.
Ladies, you doing the probabilities?
Yes.
Yeah.
Mr. Ray?
Yep.
For the roll of 2 and spin a C, how'd you get 3/4?
Not roll a 2.
Oh.
There's 3 options that aren't a 2, right?
Would it be 8?
Consecutive, it should be on. I have an extra C. So spinning an A on consecutive, that means spin 1 is an A and spin 2 is an A, right? So in the first spin, what's the probability of getting an A? 1 out of 4. On the second spin, what's the probability of getting an A? 1 out of 4. So you have 1 out of 4, 1 out of 4. What do you do with them? Multiply, because it's and. So an A on the first one and on the second.
You want us to reduce it to the simplest fraction?
Yes,
I
please.
get to see you walking. She said it's
Show your work, bud. So rolling an even. How many evens are there? 2 out of. So 2/4 times not spinning a B. How many not B's are there? 3. So 2 times 3 out of 4.
But you said I had to look at
Not that much.
I would appreciate it. I got it in my head because I'm not writing it down. Unless I'm wrong.
Got good memory if you remember 4 different answers in your head.
Well, I got 6,000 spinning.
This is 1,000 sheets of paper.
What?
This is 1,000 sheets of paper.
I said, can you maybe something lazy such
That is something.
No, that's
All right, another minute. Ready?
What does that say? Not roll a what?
Not rolling 1, yep.
Oh.
In this font, the 1 looks like an L.
And not-
Alright. Roll a 4 and spin a D. What's the probability of roll a 4? 1/4. What's the probability of spin a D? 1/4. 1/4 times 1/4 is?
160.
1/16. Then we look at our sample space from previous days. There's only one time where you have a 4 and a D out of the whole 16 box sample space. So it works. 1 on 16. All right. What about spinning A on consecutive spins? What that means is you spin it once, and then the immediate next spin you get the same thing. So you spin an A first, and then again on the next spin.
Wow.
Okay? So to get an A on the first spin is 1 out of 4, right? What about getting an A on the second spin? And since it's an and statement, we multiply. Okay? Anytime you talk about consecutive spins or consecutive flips or consecutive whatever, consecutive events, you multiply the probabilities because it's an and statement. Okay? It means I got this first and second. Okay? So 1/4 times 1/4 is 1/16. Good. What about rolling an even? What's that probability? 2 out of 4. Good. Now pay attention, please. Not spinning a D. What's that probability? 3 out of 4. So 2 over 4 times 3 over 4, what does that equal? 6 over 16. Can I leave it like that? No. Take a 2 out of everything and we get? 3 over 8. Thank you, internet connection, for losing. Okay. Last one. Probability of not rolling a 1. What's that probability?
3 out of 4.
Probability of not spinning a D.
3 out of 4.
3 out of 4. So this one is 3/4 times 3/4. 3 times 3 is 9. 4 times 4 is 16. So now what we've done is we've found a replacement for making that big sample space. All right? If I know the probability of A and the probability of B, and I want to find the probability of A and B, you just multiply those probabilities. Instead of making a sample space and seeing where both of them happen, you can just multiply the probabilities. All right? Do you guys see how this might be more useful than drawing that big sample space every time?
I like doing
You like drawing the sample space? Okay. You can still use that if you want to. Okay? Both ways work. All right, any questions? Any questions? All right. Let's try the next one. What do you guys think the next one is? Or, you think it's the division? Close. It's the addition rule. Okay? Man, probably think, Mr. Branch, addition after multiplication? That doesn't make sense. It's easier. But you'll see why in a second. All right, or statements. In an or statement, that means one or both can happen, right? We talked yesterday about inclusive versus exclusive ors. All these ors are inclusive. It's like when my daughter wants to have carrots and broccoli with dinner. Or sorry, if I say you can have carrots or broccoli and she takes both, I'm okay with that because they're both good for her, right? Right? It's an inclusive or. Or she says, I want an apple and a carrot. Okay, wonderful. They're both good for you, right? But when she says she wants cookies or ice cream, that's no. No, can't do that, right? She can't have both cookies and ice cream.
If you got a small amount.
Oh, maybe a small amount. Well, let's compromise there. All right. But these ors are all inclusive, meaning you can't have both. Both is okay. It's like 6 months late. All right. In an OR statement, probability of A or B means the probability of event A or event B or both occur. So event A or B or both.
How are you supposed to know which?
All of them work. Okay. We'll talk about rolling a 2 and swinging A here in a second to clarify. And the way we calculate this probability is using what's called the addition rule. Okay? The addition rule. Probability of A or B equals the probability of A plus the probability of B minus probability of A times the probability of B. It's called the addition rule. Yes. That's why I gave you a note that have all the stuff in there, but that's just probability of A times probability of B. Yep, minus A times B. That's a great idea for a question. For an example. You can go back and look at all my YouTube videos and keep track of which shirt I'm wearing. And then figure out the probability I wear a specific shirt on any given day. It'd be kind of fun.
What do you just collect all your videos?
How many videos do you have?
This year, well, every day I teach, I make one in physics and one in this class, so that's like 2 videos. I probably make about 10 videos per unit, so that means I have 70 videos. No, wait, 60 class, so about 60 videos for this class this year.
East.
Maybe more examples, stuff like that. All right. So, we all good? We good? Okay. So let's talk about the sample space real quick. The first example down here is rolling a 2 or spinning an A. Okay? If I look at my sample space from a couple days ago, all right, we're here in blue. All right, rolling a 2 or spinning an A. Which options are they? The ones that have a 2 or an A or both, right? But we can only count the both one how many times? Once. Okay, so if I look at the 2's, there's 4, right? If I look at the A's, there's 4. But this box right here is special. Why is that one special? It has both of them. So if I count that box twice, I've counted an event twice, haven't I? Right? So this probability of a 2 or an A is not 8 out of 16. It is 7 out of 16. Right? You guys remember doing that? Right? These 4 plus these 3, because I already counted that one. Right? You guys remember doing that one? So there's a way we can do that without making the sample space. And the way we do it is with the addition rule. Okay? So for a 4-sided die, we have all these probabilities already. 1/4, 1/4, 1/4, okay. 1/4, 1/4, 1/4. Spinner. Okay. Everything's filled in. So I want to do this, but for rolling a 2 and spinning an A. So A is rolling a 2. So what's the probability of rolling a 2? What's the probability of rolling a 2? 1/4, right? What's the probability of spinning an A? 1/4. Minus 1/4 times 1/4. Right? It's kind of like, awesome, I get to add and multiply fractions. Yay! I'm excited. Okay. So what's 1/4 plus 1/4? 2/4, right? Or 1/2. When you add long, you don't add the bottoms, just the tops, because the bottoms have to be the same. Okay? When you multiply the bottoms. So 1/4 times 1/4 is 1/16. So what's 2/4 minus 1/16? We need to make them having the same denominator, don't we? Yeah? So if I want to turn this 4 into a 16, I need to multiply by 4. So I need to multiply the 2 by 4. 2 times 4 is 8. 4 times 4 is 16. So 8 sixteenths minus 1 16th. What does that equal? 7 sixteenths. Is that what we got using the sample space? That's what we got over here using the sample space, wasn't it? 7 sixteenths. So the equation works. Right? Yay. So we don't have to make sample spaces anymore. Yay. Okay. But you're probably looking at the equation and saying, that looks like a lot of work just to get an OR statement.
Yep.
Okay. It's so much longer than the multiplication rule, right? There's more steps. So, question is, why do we have to have that A times B at the end? What is that?
The bottom part.
No.
Top part.
What is A times B?
Number.
That means it's A and B. Remember our multiplication rule from the previous part?
Yeah.
The multiplication rule we just learned, right, Faith? Right, Maggie? Right, Alyssa and Serena? Yeah? Goodness, yeah, it's fun. Did you guys start to eat turkey for lunch?
Yep.
Okay. So, this is and, isn't it?
Yep.
Right? So why do we have to subtract the and?
Because you have to get rid of it.
Yeah, we have to get rid of.
You already counted one.
Good! We have to subtract the and, so that way we don't count the same event twice. That's why I put a star in that box, because that event could be counted twice. Right? I don't want to count an event twice, so we subtract the and. So why do we need to subtract the and? Okay. So we do not or don't count one event twice. Does that make sense? And that's why we do the addition rule second, because we need the and rule to do the addition. All right, any questions?
We're done, right?
No, we're not done. Okay. There are 6 examples I want us to work on.
Nope.
Okay. Now we already did one. We'll do another one together just so you can have a little more practice.
We just do all of them.
Yes, you can do all of them. Okay. So, this first one was 7 sixteenths, right? Okay, what's the probability a not roll of 4?
1 out of 4. 3 out of 4.
3 out of 4, right? Plus, what's the probability it's going to be? 1/4, right? And that's not it, because we also have to we have to subtract, so we don't want to double count the 3/4 times the 1/4, right?
What? That part.
Okay, because this is 3/4 times 1/4. That's not rolling a 4 and spinning a B, right? If I don't subtract, then I might double count a region on my sample space. Okay? Because look at the sample space, right? We have 1, 2, 3, 4, A, B, C, D, right? My not 4s is 1, 2, and 3. So there's 3, 6, 9, 12 that are not a 1, 2, or 3. Or they're not a 4, sorry. They're 12, they're not a 4. Do you see that? Yeah? Okay. Or spin a B. How many B's are there? 4. Right? So that means if I add 4 to 12, I get 16. That means it's impossible for me to not satisfy this probability equation. So it'd be 1, wouldn't it? But the problem is, if I count the 3 in each row that aren't a 4, I'm counting these ones how many times?
3.
Twice, and I can't do that. Because now my events, instead of being out of 16, they're out of 19. Okay, does that make sense? So that's why I need to subtract the and. Because I can't count the ones that overlap spin a B and not a 4 twice. Okay? So we have to subtract it. Alright? So 3/4 plus 1/4, that equals, left my marker up too long. How much? 1. So 3/4 plus 1/4 is 1. 3/4 times 1/4 is 3/16. So 1 minus 3/16 is 7/16. No.
9.
No. 16 minus 3, guys. 13. Good. 13/16. Okay. Any questions? All right, I'd like you guys to try the other 4. Okay. Try the other 4, please. Nothing exciting in social media today, huh?
My phone's vibrating.
Can't read it over there. They do.
Can we get a negative fraction?
No, you cannot have a negative fraction. Well, you can, but none of these answers will be negative. Alyssa Picardo, please. Thank you. Stuck? Probably only 3. What? Okay, what's probably only 4? So 1 on 4 plus 1 on 4, right? Okay. Minus. Probably rolling a 3 and 4. You roll a 3 and 4. Guys, remember the multiplication is the and part, right? So if you have events that are mutually exclusive, what does the and do? Mutually exclusive means you can't have them both, right? Right, guys? Okay, think to yourself as you're going through, are there any events that are mutually exclusive? If they're mutually exclusive, then the and part should automatically become, what do you think? If they're mutually exclusive, then the and part should be? What do you think? Alright, we'll learn it in a second. What's that?
When it says like 1 is greater than 4, wouldn't it be 4 out of 16?
Can you ever roll a 3? What is this multiplication part called? Because that multiplication part, right? That is A and B, isn't it? Right? You have them both. No. So what's the multiplication part? You have them both? So this is all multiplication equals. Alright, try these out. Okay. I think those that are trying them are pretty close to being done. Those that aren't trying them, we'll wait all day. We won't get anything. Alright, so probability of rolling a 3. What's the probability of rolling a 3? 1/4. What's the probability of rolling a 4? 1/4. Now I'm guessing a lot of you then did this. and got 7/16. Is that correct? No. This multiplication part, this is an and statement, isn't it? Right? This right here is an and. This means 3 and 4. Can you ever have a 3 and a 4 on the same roll? No. So what's this probability right here? 0. You cannot have a 3 and a 4. So this probability is 0. 1/4 plus 1/4 is 2/4, which equals 1/2. So why is this 0? Good, we can't have both 3 and 4, right? 3 and 4 are mutually exclusive. They can never happen together. Okay? What about roll a 3 and spin a C? What's the probability of a 3?
1/4.
1/4. What's the probability of a C?
1/4.
1/4. Can I have them both on the same roll?
Yes.
Yeah. So 1/4 times 1/4 minus 1/4, 7/16. Right? Roll a 1. What's the probability of roll a 1? 1/4. What about not spinning a D? 3/4. So we subtract of the 1 and the D. And we get? We get what? 3/16. Last one. Spinning A or spinning B. Can I get A and B on the same spin?
No.
No! These events are mutually exclusive. They're not allowed to happen together, are they? It's like raining and snowing. Well, that happens. Never mind. It's like sneezing and breathing at the same time. Can't happen.
Sneezing and keeping your eyes open, you can't do it.
I heard of a guy who did. He lost his eye.
Is
That's a joke. All right. All right. Texting and driving, right? They can't happen together.
Yeah.
Okay. Oh my goodness. They shouldn't. You're scaring me now. All right. So spin an A or spin a B, right? Spinning an A is 1/4. Spinning a B is 1/4. Can I have them both? No. So we subtract 0. Okay. So you subtract 0 because the multiplication part is an and statement. We can't have them both. Right? So what does this become? 2/4 or 1/2. Any questions? Any questions? All right. Last thing at the bottom of your page, then we'll get to, then we'll be done. Okay. There you go. And or statements. Oh, I forgot. And mutually exclusive events should be an and, not an and. And mutually exclusive events. Give an example of mutually exclusive events from the situation of the 4-sided dice and the 4-section spinner. Call them event A and B. Hi, Justin. Good, you. All right. I'll get you a copy of the notes, bud. All right. So give an example of mutually exclusive events from the situation of the 4-sided die and the 4-section spinner. All right. Faith, wake up. Serena, wake up. Serena, that's the second time I've said getting you to stand. Okay. Faith, let's go. So, anybody know 2 mutually exclusive events? No? Nobody?
A and B.
Okay, doing what? Spinning an A and spinning a...
C.
A. Oh, one.
Oh, we can't...
C.
B.
What?
Do what you said.
You said it with usage. I already said A and
Okay, B.
B. Right. So, on the 4-section spinner, man, we cannot spin an A and a B at the same time, right? That's impossible. Right? Or if you're a Simpsons fan, that's impossible, says Ralph Wiggum. Okay? So, event A will be spinning and A. Event B will be spinning AB. Right then. Okay. So, calculate the probability and explain what this means for each. What's the probability of A and B? Now some of you are thinking, this is easy. Spinning in A is 1/4. Spinning in B is 1/4. Multiply them together and I get the right answer, right?
No.
Who's thinking that?
No.
1/4 times 1/4. Who's thinking they do that and they get it right?
No.
No. Why no, Faith?
It was either or.
Nope, this is an and statement.
Oh, then I don't know.
Okay. Can A and B happen together? No. So we don't do this. We just say it is 0 because 0 means it can never happen. Okay? It's like Mr. Bransteiger's hair purple. Probability is 0. It'll never happen.
What if you had to?
It won't happen. I'll just shave it. Get that in my hair. It's gone.
What if your kid told you to? If he had like cancer or something?
I'll just shave my head. Support it that way. Why are you being all morbid with me?
No, but like, what if he wanted?
Why are you putting bad things like that in my thoughts?
Yeah, take that back.
Okay. Probability of A or B. Probability of A or B.
Plus 1/4
Just 1/4
minus 0.
minus 0, right? So since A and B are mutually exclusive, the probability of A or B is just the probability of A plus the probability of B. Because they're mutually exclusive. Right? We can write the and statement on there if you want. But we know this will be 0 because they're mutually exclusive. Does that make sense? Does that make sense? So for this case, it'll be 1/4 plus 1/4, which is 2/4 or 1/2. Right? So finish the sentence. For mutually exclusive events, what do you think? The probability of A and the probability of B is always 0. Okay? For mutually exclusive events, the probability of A and B occurring in the same outcome is 0. I know I added some stuff to that, Luis. Oh. Now what I want to do. So for mutually exclusive events, if you want to make it more general instead of A and B, you can say for mutually exclusive events, the probability that both occur on the same outcome is 0. So you could say that as well. Does that make sense? Guys, does this make sense? Any questions?